Good morning, class. We are looking at section 3.4, the product and quotient rules. My apologies. Good afternoon. All right. So we have looked at basic differentiation formulas, and now we're going to expand it to the product and quotient rules. So reminding everybody of the good old rise over run, delta y over delta x. And these are various ways of writing them. There's nothing brand new. As Q gets closer and closer to P, the secant line gives rise to the tangent line, and therefore the tangent line is the limiting position of a secant line. And when we find the limit, this limit represents the slope of a tangent line. F prime of A is the limit of f of x minus f of a over x minus a as x approaches a. If you use this one, x approaching a, and this one, limit of f of a plus h minus f of a over h as h approaches u. When we use the point slope for this pair, a comma f of a, it gives us the equation of a tangent line. We don't have to memorize. Point slope is good enough. And we can generalize this concept into the differentiation function or the derivative function. F prime of x is the limit of f of x plus h minus f of x over h as h approaches u. The product and quotient rule, reminding you of dy dx and its definition. The constant, the derivative of x equals 1. The constant multiple says if you want to take the derivative of c times f of x, you can take the c outside the differentiation. The sum and difference rules say that the derivative of the sum is the sum of the derivatives. The derivative of the difference is the difference of the derivatives. These are the formulas we have seen. The derivative of a constant is 0. The power rule, the derivative of x to the power of n is n, x to the power of n minus 1. The derivative of kx is k. K is a number, a constant. The derivative of e to the power of x is itself. The derivative of sine is cosine. The derivative of cosine is minus sine. The derivative of tan x is secant squared. Cotangent x is minus cosecant squared x. Secant x is secant x times tan x. Cosecant x is minus cosecant x. Cotangent x. Here's the product and quotient rule. And I want to go with the shorthand notation. It makes it easier to me. F is f of x. G is the g of x. The products, if I want to differentiate, gives me f prime g plus g prime f. And the order by which I write it may be slightly different than some text do, and you may have seen it. But the reason I do it in this fashion, it makes the derivative of the quotient rule easier. I write the same thing with the negative in between and over g squared. Okay, makes it easier to remember that. Now, the product rule, by analogy with the sum and difference rules, one might be tempted to guess that the derivative of a product is the product of the derivatives. We can see, however, that this guess is wrong by looking at a particular example. Needless to say, I have the power at the end, and you're more than welcome to look at it. You're not responsible for it. A simple example, if f of x is x, f prime is 1. If g of x is x squared, g prime is 2x. The product of these two is x cubed. As you know, the derivative of that is 3x squared. Very straightforward. However, if we want to go with f prime g prime, f prime g prime, we multiply these two, we get 2x, which is not correct. So as you can see, fg prime, we ended up with 3x squared. In this example, is not equal to f prime g prime. So that's why the analogy fails. So what about this one, f prime g plus g prime f? F prime g, one times x squared, plus g prime f, 2x times x. and they add up to 3x squared, and that works. Now, that's a shorthand notation I use, and as I mentioned, this is the order probably some of you have seen. The product rule, if f and g are both differentiable, then d dx of f of x g of x is f of x times d dx of g of x plus g of x times d dx of f of x. Instead of writing all of those d dx of this, d dx of that, if you stick with the shorthand notation, it goes a lot faster and easier, everybody. So I would write the formula and I would follow that. Now, I want you to do this at home, find the derivative both ways, and I want to tell you exactly what I mean by both ways. First and foremost, distribute, do the FOILing, simplify, and then use the power. The second method is to use the product. So first I want to look at this example, and I don't want to simplify because I want to emphasize the importance of the product rule. So if I want to do that, according to the shorthand notation, this is f prime g plus g prime f. So f prime 4x cubed minus 6x squared times g. Just write the g. 3x squared minus 5x. Plus g prime, the derivative of this guy is 6x minus 5 times f, the first function. And again, I want to emphasize this because I want to make sure everybody knows that we don't have many calculus steps, just one. Of course, you have to finish this at home. There are several elementary algebra steps. That's why I said do not simplify. So here's an example. If we put a raised dot here, it says if h of x is x times e to the power of x, find h prime and find h double prime. So I'll put a raised dot here, and I'm going to call this the f function and this one the g function. Then from the memory, I'm going to write this formula. F prime g plus g prime f. So f prime is 1 times g, which is e to the power of x, plus g prime, the derivative of e to the power of x is itself, e to the power of x, times f, which is x, and I'm done with calculus. I factor e to the power of x, and I get 1 plus x. To differentiate again, now I'm going to call this one f, this one g. So I want to reuse this formula, f prime, the derivative of e to the power of x itself, times g, 1 plus x, plus g prime, the derivative of 1 plus x is 1 times f e to the power of x. Again, I'm done with calculus. I'm going to factor out e to the power of x. The first one gives me x plus 1. The second one gives me plus 1. So I have x plus 2. By the way, x plus 1 or 1 plus x makes no difference. Y equals x squared times sine x. I'm going to put a raised dot. I'm going to call this f. I'm going to call this g. And again, I'm going to use this formula. I'm going to write the formula for me and use it. F prime, this gives me 2x times g sine x plus g prime, sine gives me cosine, times f x squared. This is extremely important to put the x squared in front because one may be under the assumption this is x cubed, which is awkward. So you put the x squared in front. If you factor out the x, it's fine, but it doesn't make any difference. All right, class. So let's say this is the f function, this is the g function, and write this formula and follow it. So I need f prime, which makes it 2x minus 3 times g, just write x minus 1, minus g prime, the derivative of the bottom is simply 1, times f times the top, x squared minus 3x. And the bottom, just write it in a parenthesis and square it. And this is the only calculus step, and we are done with calculus. We are going to multiply 2x and x, we get 2x squared. This is minus 2x, minus 3x, minus 5x, plus 3, minus x squared, plus 3x. I'm assuming we can do the foiling fast. And so, again, these two and these two, they give us minus 5x. So 2x squared minus x squared, they add up to x squared minus 5x plus 3x, they add up to negative 2x. Now, anytime you get a fraction or a fractional format or a rational function, you're going to ask yourself, can I simplify it further, which means, is there a common factor between the top and the bottom? First and foremost, the bottom is x minus 1 squared. So if there is a common factor that you can drop, would be some sort of a x minus 1. Okay, that's the first thing. Secondly, do we have a common factor or not? I'm going to remind you of what we learned in elementary algebra. Ax squared plus bx plus c equal to 0. X is minus b plus minus a squared of b squared minus 4ac over 2a. This is called the quadratic formula. What's underneath is called the discriminant, b squared minus 4ac. If it's positive, you have two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. If b squared minus 4ac is 0, we have one real solution. If b squared minus 4ac is less than 0, no real solution. And we have two complex solutions. So pay attention to this. If b squared minus 4ac is a perfect square, which we mentioned it here, perfect square number, then ax squared plus bx plus c can be factored. That's the key. Can we factor this? Well, as you can see, this is 1x squared. That means a is 1, b is negative 2, c is positive 3. I'm looking at the numerator only, and I want to evaluate b squared minus 4ac, which gives us negative 2 quantity squared, which is 4, minus 4 times 1 times 3, which is minus 12, giving us negative 8. Not only it cannot be factored, even if you look at the solution, there are two imaginary solutions, and that's the key, everybody.